Hello students, welcome back. In the previous videos, we went through these two problems, 3.3a and 3.3b. They're both about exponentials. Now C and D are about trigonometrics, so let's talk about those. They're a little bit different. Okay, all right. Let's take the Laplace transform of each. So script L of y double prime plus 4 script L of y equals to the Laplace transform of cosine of 3t. Okay, this is the second derivative. That's the original, and that's the right-hand side. Okay, what is the Laplace transform for the second derivative? S squared y minus s y of 0 minus s to the 0 power y prime of 0. I changed my mind. Let's put all those s's back here. Okay, all right. Plus 4 times just y, because I don't have first derivative, it's just the original function. So that's red, that's black. And now, what is the Laplace transform of cosine of 3t? Here's the summary, and here's a table with sine and cosine. Looks like it's here. Cosine of bt is s over s squared plus b squared. Let's use that. Cosine of 3t, so b is 3. So this is s over s squared plus 9. Okay, all right. Let's simplify this thing a little bit further. What is y of 0? Y of 0 is, are we doing C? Okay, y of 0 is 0, so I don't have this. This one just drop out. And then y prime of 0 is also 0, so I don't have this one at all. Okay, things are getting a bit too simple. Or maybe not. It may get complicated enough later, who knows. So that's what we have. So dividing by s squared plus 4, I'm gonna get s over s squared plus 4, s squared plus 9 with this. So it is possible to take partial fraction here, and then I'm gonna get as plus bs form, as plus b form with respect to this quadratic, and then another as plus b form with this quadratic. Set those up, and then you can solve the system of 4 equations, so 4 unknown. You can get those done. But of course, I'm not going to do that. I'll use computer algebra system for this. And what did I get? I got s over 5s squared plus 4, or let me write it as 2 squared, minus s over 5s squared plus 9, or 3 squared. That's what I got. Let me copy and paste this thing. Okay, that's far more legible. And let's color code this one in blue and this one in some other color. Let's say, okay, magenta or pink. Okay, y of t is therefore s over 5. 5 is a coefficient, so 1/5 s over s squared plus 2 squared, cosine of 2t. And 5, that's coefficient, 1/5 cosine of 3t. And that's blue. And that's magenta, that's pink. This doesn't look right. Did I misread or something? Oh, it's okay. It is okay. No problem here. No problem here. It's gotta be right. Let's check. So 1/5 cosine of 2t minus 1/5 cosine of 3t. And then let's simplify the given differential equation. Second derivative plus 4 original t minus cosine of 3t. Left hand side minus right hand side. And yes, we got 0. So the solution here satisfies the given ODE. Now, how about the initial condition? Y of 0 and y prime of 0. Are they both zeros? Yes, they are both zeros. So we have correct solution there. Okay, we have enough time for the next problem, so let's go ahead with the next problem here. And I just copy and pasted the previous solution because I think I can recycle this a little bit, at least to a certain degree. You see, the left-hand side is the same, so I can use the left-hand side, no problem there. Here I have 9t sine of t, so I need some work. 9, and then here I have t sine of t. Left-hand side is the same, but of course this is wrong. I did 9, by the way. And this is wrong. I have to find out the Laplace transform of t sine of t. Okay, let's go to the summary. Where do we have t sine of t? Not here. Do I have it here? Well, I don't have it here either. And if I go over to my textbook, probably there is a bit bigger formula table so that I will be able to find what the Laplace transform of t sine of t is. But let's pretend we don't have that kind of luxury. Okay, in that case, let's see, what choice do we have? Laplace transform of t sine of t is equal to the integral from 0 to infinity e to the negative st t cosine, no, sine of t dt, and we have to do this computation, and oh my goodness, this doesn't look very promising. I can use integration by parts here. There's no question about that. It's just that I'll have to do it so many times that it's gonna be really horrendous. Well, I use apart commands to do this seriously horrendous computation of the decomposition by partial fraction. Why don't I do the same thing? Use Mathematica to calculate this definite integral. Let's go ahead and do that. Integrate e to the negative s times t times t times sine of t dt, well, we just use comma t, integrated with respect to that. What do I get? That's what I'm getting. I am getting minus excuse me, this is indefinite integral. We should be getting definite integral. Okay. That makes more sense. Okay, I'm getting 2s over 1 plus s squared squared. 2s over 1 plus s squared squared. So that's what I have over here. This is the green part. And then let's put all these together as justification. By the way, I didn't really want to show you this, but looks like I'd better do this. The definite integral here, sometimes it fails, then you can do this. Just ask Mathematica to find out Laplace transform. And this is not very good because it is basically asking Mathematica to, hey, give me a solution. I don't know what that is. I don't understand anything. Just give me a solution. That kind of thing. So it's not very good, but well, excuse me. I don't have this exponential part. Just t sine of t. Okay, all right. Okay. So we got the same thing. So, okay, we have all that. What do we have next? Let's see. Y of 0 is 0, so that one drops out. And y prime of 0 is also 0, that too drops out. So we have s squared plus 4 times y is equal to 18s over 1 18s over 1 plus s squared, total quantity squared. So y is equal to 18s over s squared plus 4, and then 1 plus s squared, total quantity squared. That's what we have. And then I'm going to ask Mathematica to decompose this. If you do it right, you're going to get this. Let's see. 2s over s squared plus 4, or equivalently speaking, 2 squared, minus 2s over s squared plus 1 plus 6s over s squared plus 1 total quantity squared. And let me expand the font. That's what I got from a part command. Let's see. Blue, and then red, and then green. So what is the solution? Let me take Laplace inversion. 2s s squared plus 2 squared. Let's go to this table. And s over s squared plus b squared corresponds to cosine of bt. So this 2 is coefficient. You're going to get 2 cosine of 2t. And that's the blue solution. Next, 2s s squared plus 1, or 1 squared. Let's go to this s over s squared plus b squared. That's cosine. So we have 2, which is a coefficient, cosine of just 1t this time. And that's red solution. Now, how about this? Well, here, 2s over 1 plus s squared total quantity squared corresponds to t sine of t, right? We have 6, so let's put 2 there, and then multiply by 3 later. So this is 3 times the coefficient, and then a Laplace inversion will be t sine of t. And that's the green part. Looks like that's the solution I will get. Let's check. Two cosine of 2t minus 2 cosine of t plus 3 t sine of t. And then simplify y double prime of t plus 4y of t minus right hand side 9t times sine of t. Okay, it satisfies the differential equation. And how about the initial condition? Yes and yes. So this is the solution. Wow, it was a challenge problem, but it turned out okay. We had to use some technology in the middle part, but that's normal.